Okay, so before we get started, we're going to look at one of the homework problems. I've got it right here. If you know which number you want to look at. 51. All right, guys, so we're going to look at number 51. Solve the equation and check your solutions. So we're looking at square root of 1 minus 3a is equal to 2a. And yes, this one here, we are able to graph and get one of the solutions for it, but the other solution that we get at the start, we'll have to actually factor. Because for this one here, there is indeed one radical, and it is by itself. So we can put both sides to the nth power. On the left-hand side, our square root and square would cancel, leaving us 1 minus 3a is equal to. The right-hand side, we have 2a squared. Now, since there's not a plus sign or something in the middle, we can actually square both terms. We're multiplying it by itself, because 2a times 2a is 4a squared. Now, our step number 3, which has never come in play, is there any radicals left? Well, no, we're just going to go on and solve. Now, there's different ways we can solve this, but we need to get this equal to 0. So what we could do is subtract 4a squared from both sides, which will tell us that we have negative 4a squared minus 3a plus 1 is equal to 0. So we move the negative, or 4a squared over, and I rewrote it in standard form. So we have a squared a constant term. Now at this point here, we can graph it. Clear both of these out, because we have negative 4x squared minus 3x plus 1. Yep. Graph. So we do see it crosses the x-axis in two locations. One of them is at negative 1, and we don't have a second value, but there is one. Now, we didn't specifically go over this theorem, but there is a theorem called the intermediate value theorem. Intermediate value theorem that states that between 2 points, there is a 0. Now, if we look at the graph, at negative 1, we do see that it goes above the x-axis, and then somewhere to the right of it, it goes below the x-axis, yes? Above the x-axis, the y-value is positive. Below the x-axis, it is negative. That makes sense, yes? So according to the intermediate value theorem, if we look at the y-values, at 0, the y-value is positive 1. At 1, the y-value is now negative 6. Yes? Now, what that means, because it went from positive to negative, at some point between 0 and 1, it must have crossed the x-axis. Thank you. Careful. So the intermediate value theorem states as if between any 2 points, the output value, the y value, goes from positive to negative or negative to positive, it means there must be a 0 between it. Intermediate, in between. That's all the intermediate value theorem states. And really, according to that theorem, we could then start closing the gaps between it from 0 to 1 and try to get it smaller and smaller to where we get to that point. But for us, there's ways that we can do it in the graphing calculator. We're going to graph it, not graph it, factor it. But to help us factor it, it's kind of been nicer to have the value in front of a squared, our first term, to be positive, not negative. Well, we can fix that by either a, multiplying by negative 1, or dividing by negative 1. It'll get to the same place. Because 4a squared, negative 4a squared times negative 1 is 4a squared. Negative 1 times negative 3a is plus 3a. 1 times negative 1 is negative 1. And 0 times negative 1 is, well, 0. So this makes it a little bit easier to work with. We'll have 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are opposite, positive and negative. Factors of 1 are 1 and 1. I picked it because, well, there's only one set of factors. It's a little bit easier to work with. Now we'll look at the factors of 4a squared. Well, a squared is A and A. Now we're looking at the factors of 4. We have 1 and 4 or 2 and 2, yes? Now, I believe this was brought up the other day because we did factor the other day. Because we would need 1 and 4, yes. And we solved one of them by graphing, and then I went on and factored it afterwards. And I want to say, Kaylee, you mentioned the fact that I flipped the signs, yes? Well, and that actually comes into play here, because since we know, according to graphing, one of the values is -1, yes? So in the factored form, it's actually not going to show up as -1, it's going to show up as +1. Does that make sense? So one of the factors is actually a plus 1. So that means the 4 should go over here. Now, again, as we've seen with factoring, there's not a lot of hard set rules that work every single time. It's more once we start seeing the patterns, we can start utilizing that pattern. So if you don't see it, that's perfectly fine. Because we can still plug 1 and 4 in and check. And if we check this, a times -1 is -a. 1 times 4a is plus 4a, giving us positive 3a. So this is the setup we want. Now the a plus 1 is going to be 0. And 4a minus 1 is 0. Well, a plus 1 really doesn't tell us much. More than we already know that a is -1. Now the other side, 4a minus 1 equals 0. Well, we could add 1, telling us 4a is equal to 1. Then we would divide by 4, telling us a is 1/4. So we have two solutions, -1 and 1/4. Questions on how we got these here? Okay. Now back up to the top. We're going to check this here. I'm going to check with -1 first. We have the square root of 1 minus 3 times -1 is equal to 2 times -1. 2 times -1 is -2. Now at this point here, we can already throw -1 out. Because our radicals, the number that comes out of a square root, an even root, cannot be negative. So that's not going to work. Now if we plug this in and work this out, we actually get 1 -3 minus 1 is +3, giving us 4, telling us 2 is equal to the square root. Square root of 4 is 2. 2 equal -2, that does not work. So we can say that a equals -1 is an extraneous solution. It's a solution that we get from solving, but does not work in the original context. Does that make sense? Now, the other value we found is 1/4. And we can plug it in. Now, square root of 1 minus 3 times 1/4. And I would just grab a calculator. 1 minus 3 times 1/4 is a half. And 2 times 1/4 is also a half. So our solution is a is 1/4. That's it. Questions on this here? You know, because all the other ones worked out to be nice integer numbers. And I'd say one of the biggest differences between what we've done in here, they take things a step or two further. And for the most part, we get more fractional, not nice number answers in college algebra than we do in Algebra 2, but that's about it. So Lou, would you agree with that? For college algebra, we get less nice numbers and more fractional, decimal. Pretty much same thing. We just, not as many of the equations work out to be these nice round whole numbers. But questions on this here? Questions on the homework? Okay. the problem that we're looking at today is this one here. Square root of 2x is equal to the square root of x plus 7 minus 1. And we're going to treat this like we have up to this point. And we've had some equations that had two radicals, but we haven't had one up to this point where we've had two radicals and a number outside, or a term outside of the radical. But let's still follow the same steps because they still work. As our first step, is there one radical? If so, get it by itself. Well, part B was to even them out. You can even them out, and you don't necessarily have to. Sometimes it's nicer, sometimes it's not. But here, they're already evened out. Yes? Put both sides to the nth power. Well, our nth power in this case is 2. Now, the left-hand side works out nicely because the square root of 2x squared is 2x. 2x, because our square root and square cancel. Now, the right-hand side, when we were saying that we're taking the square root of x plus 7 minus 1 squared, we're multiplying it by itself. If the minus hadn't been there, we could have just squared both terms and been done, but here we're going to have to distribute. Now, the first thing we're going to multiply is the square root of x plus 7 times, well, the square root of x plus 7, which is technically the square root of x plus 7 squared, yes? Multiply by itself. So what can we say about the radical and the square? They're going to end up canceling out. Square root of x plus 7 times negative 1 is negative square root of x plus 7. The only way the number will go inside the radical is if it also is inside a radical. So if then say square root of 2, we can multiply the 2 and x plus 7 together. Otherwise, it goes out front. Now the next one's going to be the negative 1 times square root of x plus 7, which is negative square root of x plus 7. And lastly, negative 1 times negative 1 is positive 1. Now the nice part about all this so far is that the left side's still just 2x. Questions on how we've gotten to this point so far? Now, the right-hand side, we do have some things to simplify. Well, yes. You're welcome. So we need to combine some terms. Now, it might be nice to simplify this here because the square root of x plus 2 squared is just x plus 2. We also have our plus 1. Thank you. That's because I can't read my own handwriting. 7. Thank you, because that would have changed all the solutions and made everything look very not nice. Proper English there. Now our negative square root of x plus 7 minus the square root of x plus 7 would be what? They both have the same radical, yes?
So the egg would be like that, but the squared or whatever, how would you?
They're essentially like terms. Because we're used to seeing like terms with ax squared, bx squared, just variables. Radicals work the same way. Because we can almost think of it as negative x minus x is negative 2x. They're the exact same statement. Since I have negative square root of x plus 7 minus the square root of x plus 7, we'll have negative 2 square roots of x plus 7. Got two of them. Well, we could have done this in one step. Our last like term is our the plus 1 at 7 and 1 would be 8. We could have skipped that and just gone x plus 8 minus 2 squared of x plus 7. I just wanted to do it as those two steps so we could see, one, that the radical reduced to x plus 7. Then we added 1 to it. Does that make sense? Okay. Questions on anything we've done so far? So we've done all these steps before, because step 1 is there one radical? If yes, get it by itself. If no, even them out. Step 2, but put both sides to the nth power and we simplify. We did that. Step 3, which we've pretty much ignored up to this point, are there any radicals left? Yes. If so, repeat steps 1 and 2. So we go back to the top. Is there one radical? Yes. If so, get it by itself. So that's the first thing we can do. We can subtract 8 because we need to move the x and 8 over to the other side and the negative 2. Then we would indeed subtract x. And then we would indeed divide by negative 2. Because we want to try to keep all of our multiplication division steps to the last possible part. The only ones we do even after multiplication division is powers and radicals. Yes. Now, if this problem had been nice, the x would have had an even number in front of it. Because if it had been, say, 2x, both 2 and 8 are divisible by 2, yes? We could have divided it, the fraction would have been gone, it would have been nice. But is the radical by itself? Well, yeah, it's just the square root of x plus 7. It is by itself. So that means we can move on to step 2, put both sides to the nth power. So put both sides to the second power. Left-hand side, or right-hand side is now nice. It's just x plus 7. Left-hand side, we're multiplying it by itself. Yeah, might as well. So we're multiplying x minus 8 over negative 2 by x minus 8 over negative 2. Multiplying it by itself. Okay, I'm going to move a little bit away from the left-hand side of the screen because I feel like I keep getting closer and closer to it. So any questions on this so far? Now, before we multiply the numerator, let's actually tackle the denominator, the bottom of this fraction. Negative 2 times negative 2. Positive 4. So I might as well tackle the easier one of the two. It's not that the numerator is any harder. It's just negative 2 times negative 2 is nice and quick. So x times x is first, which would be x squared. X times negative 8 is negative 8x. Negative 8 times x is negative 8x. And lastly, negative 8 times negative 8 is, because our negative and negative make a positive, and 8 times 8 is 64. Let's combine. We can combine our like terms. Negative 8 and 8 gives us negative 16. And we get this here. So, are there any radicals left? No. So that brings us finally to step 4, to solve for x. Yes? Now the unnice, or well, not unnice, but the not nice part about this is we have that division of 4, yes? Now we did this a minute ago with factoring, yes? Because when we factored it, we didn't like the fact that the number in front of x squared was negative, yes? So we multiplied through by what? Negative 1, yes, to make it nicer. If we tried that here, what would I multiply through to try to make this nicer? Because it wouldn't be negative 1. What would make that fraction go away? 4. So, and this is perfectly legal. You can do this to make the equations work nicer for you. Now, if I multiply the left-hand side of this equation by 4, well, that 4 and the denominator would do what? Cancel. Because it'd be 4 over 4, which would simplify that out, leaving me with x squared minus 16x plus 64. Yes? Yes. If we do it on one side, we have to do it to the other. Because what this is called is using a scalar. We're scaling the problem up or down to make the numbers look nicer. On the left-hand side, we have 4 times x, which is 4x. 4 times 7 is plus 28. Is this a nicer looking equation than what we started with? Yeah. We do need to get it equal to 0. So we have x squared minus 20x plus 64 is equal to 28. And then we'll minus our 28 over and get x squared minus 20x plus 36 is equal to 0. We can factor it, yes. Or graph it. Squared 20x. So we do have one point here, yes? There's a second one, but we have to go find it. One of our solutions is 2. What's the other factor that goes along with 2 for 36? Because 36, if we, again, because it's 1 and 36 or 2 and 18, yes? Yeah. Well, negative 18 does not give us 0. 2. And 18 we also get 0. And 18 and 2. Yes, and we will need to check these. So we get 18 and 2. Now the reason I asked about that is because if we factor this, we would do our signs, and then the next thing would be factors of the first and third term, yes? Well, factors of x squared are just x and x. Now if we look at the factors of 36, we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't work, and then 6 and 6. Well, since 2 was one of our solutions, it would be one of the factors, so 18 had to be the other. Because it works out with those factors. It helps us see what our solutions would be. 18 and 2. Well, let's try 18. 2 times 18 is equal to 18 plus 7 minus 1. And again, we don't have to do this by hand. We can grab the calculator, say second square root of 2 times 18 is 6. Second square root of 18 plus 7. Yeah. A plus 1 would have been nice. It's actually minus 1, which is 18 is not good. Well, let's try the other one. Square root of 2 times 2. Well, square root of 2 times 2 is 2. Second square root of 2 plus 7. So our answer is 2. Questions on this here? Would we say this one's a lot harder than what we've been doing? I mean, in some ways, it's pretty much the same thing. We just had to do a lot more steps to get there, yes? So that's all that's changed when we have more than 1 in that number. It just adds a lot more steps to it. And keeping track of all of our terms. Because even one like this here where we have 3, it still works out to be the same, but it's just a lot more steps. And that's it. So there is not an assignment attached to this. I more wanted you to see this and see how it works than trying to give you all work with it.